Hi friends, welcome back to my channel Simony. It's me Vaishak. Today we are going to discuss about kinematic graphs and equations of motion in detail. Good. So let's begin. First of all, we have to know what is the purpose of kinematic graphs. The main purpose is to analyze the motion, analyze the behavior of moving objects. Good. So we will see that one by one. Good. Right. Let's discuss about position versus time graph. This is very important because this graph connects other graphs like velocity versus time graph and acceleration versus time graph. Good. Right. The position versus time graph for a car moving with the constant velocity is shown below. Good. So you can see that the position is linearly varying with respect to time. Now we can define the average speed as the slope of this line, slope of this plot. Okay, so how to find this slope? You take 2 points here and here, and also one corner is here, and you have to measure this delta t and delta x. Good. So here delta x is equals to 2 meter and delta t equal to 2 second. So therefore average speed is delta x divided by delta t equal to 2 divided by 2, which is 1 meter per second. So if you find the same slope here, then also you will get the same answer. Maybe this is like 1.5, but here it will be 1.5, so the ratio will be again 1. So such a kind of motion in which position is linearly varying with respect to time is known as uniform motion. Got it? So in this motion, the slope of the xt plot is constant. That means the velocity is constant. Therefore, it is known as uniform motion. Good. Right. So here is the points to remember. For uniform motion, xt graph gives the straight line plot. Slope in the xt graphs gives average speed. It's very important. Now, what happens if speed is increasing with respect to time? That means speed is varying with respect to time. So this case is known as uniformly accelerated motion. The x versus time graph for uniformly accelerated motion is a parabola basically, right? You may think, oh, it doesn't look like a parabola. Actually, it's a half portion of a parabola. Okay, right. So now the question is, okay, if the curve is not straight line, how I'm going to find the average velocity or average speed, right? So now for finding average speed for a specific interval of time, we need to take two time first of all. Let's take 2 and 4 as points and draw some vertical line so that it will touch the curve. Then we got the points A and B. Now we will draw a line from A to B. So if you measure the slope of that line, that will give you the average velocity in the time duration from t equal to 2 to t equal to 4 seconds. That is only valid for this interval. That means this delta t equal to 2 second interval. Okay. So this point B is 4 comma 3.5. That means at 4 second the position is 3.5. Therefore average speed is 3.5 minus 1 divided by 4.2, which is equals to 2.5 divided by 2, which is 1.25 meter per second. Okay, 3.5 minus 1 is the displacement. Now imagine if the speed is not constant, what will happen? Let's explore the case in which speed is increasing linearly with respect to time. So this case is known as uniformly accelerated motion. That means in uniformly accelerated motion, velocity is linearly increased. Let's analyze the position versus time graph for this case. We can clearly see that it's a parabola. The plot is a parabola. Now you may think, oh, why it is a parabola? If you take the mirror image, it will finish the complete parabola basically. Okay, right. Now the question is, what is the velocity for certain time interval? So let's take 2 and 4 as the initial and final time respectively, and their corresponding positions are given by A and B. So here A point is 2 comma 1, B point is 4 comma 3.5. So using these 2 points, we can find average speed corresponding to the time interval from t equal to 2 to t equal to 4. So that's what given here. The average speed V average equal to delta x divided by delta t, that is 3.5 minus 1 divided by 4 minus 2, which is 2.5 divided by 2. So obviously it's 1.25 meter per second. Remember, if you change the interval to, let's say, something like 1 to 4, then this average speed value will be different. Okay, good. Now let's ask ourselves, what is the speed at, let's say, t equal to 3 seconds? How we can answer it? How we can grasp the idea of speed at a particular time? For that, what we can do is, we have initially taken 2 and 4, correct? Now what will happen if we reduce the interval to something very smaller interval, maybe like 2.75 to 3.25? Or imagine again we are reducing the time duration, right? So this reduction will give you approximates instantaneous speed. Now practically how we can do that? Practically, let me talk the same with this graph, the same graph actually. But here the idea is, let's say at a time t equal to 2, you have to find the instantaneous speed. What you can do is draw a perpendicular imaginary line to the curve. Then you will get a point here, correct? Through that point, draw a tangent. If you draw that tangent, slope of that tangent will give you instantaneous speed at this time equal to 2. Now, why is that? See, as I said before, if you reduce the time duration into very small time duration, the corresponding displacement, if you measure and divide that small delta x by this very small time interval, then you will get the almost instantaneous speed. So that's why we are drawing this tangent, and its slope will give you instantaneous speed. To find the slope of the tangent, let's take this point A and this point as B, and let us find the corresponding delta x and delta t, then we can divide, right? So here point B is clearly 3 comma 1.7, and point A is something like 0.7 comma 0. Here delta x is equals to 1.7 minus 0, and delta t is equal to 3 minus 0.7. That's exactly what I have written here. 1.7 minus 0 divided by 3 minus 0.4. So it's equals to 1.7 divided by 2.3, which is nothing but 0.739. Now let's focus on velocity versus time graph. Good. So we can find the instantaneous velocity at all value of time and draw a graph. Using the tangent method, you can find velocity at each and every point, and you can note down that value in a table, and you can draw a graph like this. So here you can see it's a uniform motion graph. This graph corresponds to a uniform motion. Okay, that means the velocity is constant. You can clearly say that at any time the velocity is same. Okay, maybe like 2.5 meter per second and like that. Okay, good. So for uniformly accelerated motion, velocity varies linearly with respect to time. So the graph is a straight line but with non-zero slope. So here is the graph for non-uniform motion, or specifically here, since the velocity is linearly varying, is a uniformly accelerated motion. Remember, this is a non-uniform motion because velocity is not constant. This is also uniformly accelerated motion. because velocity is varying linearly with respect to time. In another way, we can say acceleration is constant. So same like we found the velocity from the xt graph, we can find the acceleration from the vt graph. Of course, how to find it? You find the slope. So the slope will give you the acceleration. Got it? So acceleration is equal to slope of the plot in vt graph, which will be delta v divided by delta t. So what about the delta v here? You can see this is the final velocity, this is the initial velocity, and corresponding time are tf and ti mentioned here. Okay, good. Now let's focus on acceleration versus time graph. See, here is the graph for uniformly accelerated motion, in which acceleration is constant, correct? So the slope is 0. Here maybe something like 9.8 meter per second square will be there. All right, good. Now for uniform motion, in uniform motion, velocity is constant, therefore acceleration is 0, and the graph will look like this. You can see the plot is here. It is on the time axis because acceleration is 0. So all the time acceleration is 0. Now let's focus on area under the graphs. This is a very hotspot area for AP Physics questions. Okay? The area under a VT graph for a specific interval of time gives displacement during the same time interval. So let's concentrate on this graph. I am taking this time interval delta t, that means from ti to tf. Then if you draw vertical line, you will get a closed shape like this. Now, if you find the area under this curve from A to C, the curve extends from A to C, and if you find the all area under this curve, you will get the total displacement in this time interval. So essentially this shape is trapezium, and you can divide this trapezium into triangle ABC and rectangle ABED. Therefore, the area of triangle ABC is A1 is equals to half BH, right? Half into breadth into height, correct? And it's given by half into AB into BC, AB into BC, right? So area of triangle ABC is A1 is equals to half BH, which is half into AB into BC. So that's clearly half into delta T into delta V, which is VF minus VI. Good. But we already know from the definition of acceleration, final velocity minus initial velocity divided by time duration is acceleration. Basically, acceleration is rate of change of velocity, correct? So therefore, we can write Vf minus Vi equal to A delta t. That we can substitute into this equation. Therefore, A1 is equals to half into delta t into A delta t. So A1 is equals to half into A into delta t square. Now, let's concentrate on the rectangle ABED. In the rectangle ABED, the area is A2 is equals to length into breadth, which is dE into BE, and dE is delta t into BE is VI. So we got VI into delta t. Now total area under the plot for time duration delta t is therefore A is equals to A1 plus A2, which is equals to half into A delta t square plus VI delta t. So this is the total displacement. Therefore, we can write the displacement is delta x is equals to final position minus initial position equal to Vi into delta t plus half into A delta t square. Remember, Vi is the initial speed and A is the acceleration, and of course delta t is the time duration. So we can call it as equation of motion 1 or EOM1. Now, another interesting thing is area under an acceleration versus time graph for a specific time interval gives the change in velocity during the time interval. Right? So let's concentrate on this AT graph. Of course, this AT graph corresponds to uniformly accelerated motion, and I'm taking this time duration delta t. So for that time duration, the area is actually the area of rectangle ABCD. This area is nothing but change in velocity. So Vf minus Vi equal to A delta t. Thus we get Vf is equals to Vi plus A delta t, which is the second equation of motion. We can call it as EOM2. Good. Very important equation. So let's combine equation of motion 1 and equation of motion 2. For that, let's square the second equation of motion. So Vf square is equals to Vi plus A delta t square. Now we can use the mathematical formula A plus B square is equals to A square plus B square plus 2AB, right? So Vf square will be Vi square plus 2VIA delta t plus A square delta t square. Remember, this corresponds to A square, this corresponds to 2AB, this corresponds to B square. Good, where A is Vi and B is A delta t. Good. And I'm taking this A outside, therefore Vf square is equals to Vi square plus A into 2Vi delta t plus A delta t square. And also I'm taking this 2 outside. There is a reason for that, okay? So Vi square plus 2A into Vi delta t plus half A delta t square. The reason is we have seen this somewhere. That is just xf minus xi, right? Basically that is equation of motion 1, correct? Therefore, Vf square is equals to Vi square plus 2A into xf minus xi. So finally we got the equation of motion 3, Vf square equal to Vi square plus 2A into xf minus xi. So this is EOM3. Let's put the three equation of motion together. The first equation of motion is xf is equals to xi plus Vi delta t plus half into A delta t square. What is the significance? If you know the initial position, and if you know the initial velocity, and if you know the acceleration, you can find the position at any time. Now let's talk about the second equation of motion. If you know the initial velocity and acceleration, you can find the velocity at any time. Good. Now what is the purpose of equation of motion 3? See, when you know the initial velocity and acceleration, but you don't know the time, but you know the displacement, then you can find the velocity at that particular displacement. So that is the significance. To understand these three equations of motion, we'll be doing a lot of questions in the next video. And together with that, of course, we'll be doing questions related to kinematic graphs also. So stay tuned. See you again. Take care. Bye bye.